Okay. Last week, we had been talking about shapes of molecules, and then we talked about polar bonds and whether molecules are polar or not. I know that we did some of these on this page, didn't we?
Yeah.
Whether the molecules are polar or not. E and F I would like to do today. I've just thrown those on this morning. E, PCl3. Can you take a moment to do the dot structure for PCl3? It's pretty easy. They just sit over
Guys, let's all be real.
Where's P?
Yeah, so it's like
No.
PCl. How many
It's just
electrons?
single bonds everywhere.
21.
Don't give
How
it
many
away.
electrons does B have?
I finished.
E-man, how many electrons does B have?
26 total.
26 total.
So P has 5.
B,
Selfie. Let me take a selfie.
6, 8.
It's Eric Chang.
Oh yeah, we're video sticking.
So we have to have a Lewis structure by now, yes?
Yes.
The P has a lone pair on and then
That's what I
3
thought.
single bonds to the Cl.
Boom.
Very simple.
This is like
What is the shape of the PCl3 molecule?
trigonal.
It is a trigonal pyramid. With what angle? Or 107. Yeah.
Yeah, that's what
Now-
I was about to say.
For PCl3, what's the coordination number on the P?
Quattro.
Drew, do you want to
It's 4.
No, it's okay.
And therefore, the orbitals are coming off of the phosphorus like this. 4 as far apart as they can get from each other at 109.5 degrees. But one of those is a lone pair, so that top pair of electrons is just not being shared, where the bottom ones are like this. And that's where we get this pyramid effect, is because of the presence of that lone pair is pushing down on those. Is the P to Cl bond polar? Is it a polar bond?
Yes.
Yes.
Fonkel,
I
remember,
think so,
FON
yeah.
and Cl, those are, anytime you have something attached to FON or Cl, it is going to be a polar bond. So, the P to Cl bond is polar. So you have 3 polar bonds, and they're each going down, the electrons, when I say they, the electrons are getting pulled down toward the Cl's in every case. Do the polar bonds cancel out in this case?
I don't think so.
I would say that they don't. Which part of this would be electron rich and therefore partially negative? The bottom down here. Where the more electron negative atoms are is where it's electron rich. Up here, around the phosphorus, it's electron deficient. So you have a slightly negative charge down here, slightly positive up here. It's kind of weird because you actually have a pair of electrons up here, a lone pair, and it's there pushing down these other ones, but you still consider this side of the molecule to be positive. That's weird, I know. Okay with that? Oh. Now the next one is IF5. IF5. Would you take a moment and draw the Lewis structure for IF5? IF5. If 5.
The one that comes in the middle usually comes first, right?
Yes. Almost always. A couple exceptions like water.
Oh,
Oh, jeez. That would be deep. Deep water.
I get it. 7 times 6.
yeah.
Well, it's a lot.
Would that be a,
No, when you have 2 of the same element combined together, they're
oh,
Do you have a coordination number actually?
Yes.
I thought I was just confused.
And do you in this case?
Yes.
Yes, you do, and that's very possible.
Yeah, I know.
My 90-degree angles, I hope you don't have a protractor. Not good.
why would I have a protractor?
All right. Do you have a shape on this one?
Yeah.
1, 2, 3, 4, 5. That's like octahedral.
No, it's like pentagonal pyramid.
No, it's octahedral.
If it's a coordination number of 6, would there be one on the bottom as well?
A lone pair on the bottom.
So,
Yeah, octahedral.
Told you.
Oh,
no,
no.
hold on.
Wait.
it's not a lone pair,
Wait,
it's a
we
square
didn't learn
pyramid.
this.
Square pyramid.
Square pyramid, we got it.
Yes, it's a square pyramid.
Less than 90 degrees,
I probably did that right on
I think.
I have to.
So, I'm having.
Just like
Okay,
four
so
football
this
men.
thing is a square pyramid. Are the bonds polar? Are the I to F bonds polar?
No.
Yes.
Yeah.
Boy,
Yeah.
Yeah, F in there. F is the most electronegative element. So the F is yanking the electrons away from the I in all cases. Do the polar bonds cancel out?
I don't
No,
They don't cancel out. Now, if the molecule looked like that, yeah, they would cancel out
Yeah.
because you've got all the bonds are pulling the electrons out 90 degrees from each other. You don't have one side that's partially negative, one side that's partially positive. But in this case, you've got in that plane where most of the atoms are, that's not a polar side. But when you have this F and it's not counteracted down here on the bottom of it, then yeah, they don't cancel out and this is a polar molecule. This would be the negative side, then down here is the positive side. Yes?
Less
Cool,
than
cool.
90 degrees.
Yeah.
So would the base part be neutral then?
It would be, yeah. Yep. These problems are at the very end of chapter 8. Do them thoughtfully, read the solutions guide. This is not the most easy thing when you're trying to determine whether molecules are polar. Even if they have polar bonds, they may cancel out.
So this is-
That was polar,
Polar.
yes, because they didn't cancel out. And this is polar. VCl3 is also polar. Because you got polar bonds, they don't cancel out. It's like a pyramid shape. All right, Drew, that was the only writing I had to do.